Um, Hello, everybody. My name is Irfan Rashed. Thank you, Michael, for that introduction. And it's a pleasure always to be part of the Expo. And it's been a phenomenal run since 3 in the morning. For this kind of session, and then all the sessions have been exceptional and keep upgrading every time we have an expo. So my topic for today in basic research, what I do is working on small satellites as a systems engineer, and my present graduate research is on small satellite constellations. So unfortunately, I would not be able to take you through the work I'm doing due to some restrictions, but I'll take you through what exactly FreeFlyer can give you in terms of small satellites as a whole. So when we talk about LEO, it's mostly about constellations on low Earth orbit and then having applications similar to that. But when we go beyond LEO, it's much more bigger scenario. So I'll take you through where and how exactly my PhD research is heading towards, and what we can accomplish as a broader view, and what are the features and what are the versions I have used, and my experience as a user since 5 years. So to start with, I want to take this little minute to express my gratitude to AI Solutions, great friends, people with value, and a lot of mutual respect here in this team. I have been working about 5 years with the team, and exceptional people with a lot of talent, and a lifelong association, I would say, because such a wonderful experience so far. I started working while I was in industry, and now I'm in graduate school. The experience keep enhancing every single day, so I get inspired by this team a lot, and then get focus from them on all these astrodynamic aspects of not only the constellations or small satellite part of it. The overall picture of the team is exceptional. Passion, definitely, I would say one of the finest passions in the industry comes from AI Solutions. The FreeFlyer is one of the teams which actually upgrades and takes it at a different level. So I wanted to express my gratitude and then present my thanks to the team. Since I have been working, it has been a phenomenal experience since then. So talking about the general perspective of how we see small satellites to be, it's a new space era. We want a lot of different solutions in this industry as a whole. It's going to be one big industry in it by next decade, and then a lot of business coming through into this. And what FreeFlyer can do as a whole for developing small satellite astrodynamics part of it is exceptional. It may sound very general in a way, but when you actually put in your configuration into FreeFlyer and test your small satellite detailing, it's a extremely different experience overall. So it's a multi-purpose and resource saving part of the satellites, what we are talking about. Not only the constellation aspect of it, but overall, if you even have formation flyings with small satellites, FreeFlyer with all its versions have been very productive in analyzing the astrodynamics part of it, operations, functioning, and then even the minute functions and parameters can be set and analyzed very clearly. So talking generally about the small satellites, definitely any kind of configuration can be made in the FreeFlyer versions, and analyzed to an extent where you can put in your own customizations and then put the value added analysis and research into the configuration you are working for. So we are not here to only do the small satellite analysis, but solve the real concerns in present NEWSPACE era. So FreeFlyer has a very higher stage set for itself in global market in NEWSPACE era. So I take you through what the performance part of it is also about. So definitely space economy, as I mentioned, it's going at a different level. It's going to be a $12 billion economy by 2029. So a lot of work to do, a lot of research coming in into the small satellite part of it. Many people question the impact and robustness of the satellites, but definitely once we are there, we have put our satellites, we have been successful. Definitely FreeFlyer has been a very stepping stone, I would say, to analyze the configurations and the orbits we want to test for our satellite. So definitely there's a lot of competence. We have to synergize our energies into the research, what we want to grow with small satellites being the frontliners in the space industry today. So why do we need constellations overall? We know there are a lot of different aspects associated with constellations formations. Definitely on the US side of it, people have done a lot of different works on the constellation formation part of it specifically. But why we need constellations overall is because of the faster data transmission for the applications of global warming, climate, and a lot of different aspects of it. So different major players globally are operating and having many different operations relating to the small satellite constellations. But overall, the applications come very handy and is the very specific need of the hour with a real need for imagery. Imagery at our side, when we talk about Asia, we have a lot of requirement for imagery, which is cost effective. So when we don't have cost effective solutions here in this region, we have scarcity of data itself. So it says a lot in that sentence that we need a lot of research on this ground to maximize our outreach towards the global audience and specifically to the one's needy and cost-effective regions as a whole. So internet is one of the main priorities most of the times to serve like Starlink in a way, but we need more cost-effective solutions with constellations in coming times. And definitely, I say Capella, Starlink are doing their part of data relays, but we need more cost-effective solutions. And FreeFlyer plays a very important role, as we have seen for the telescopes as well. It does a lot of different insights and analysis, value-added analysis, I would say, to generate that cost effectiveness in your piece of work. So constellations are one of them. So many people ask me why exactly autonomy is needed into any kind of constellation or even a formation or just an individual satellite, because we want to grow as a multi-body, multi-planetary species in a way before we explore all this LEO orbits and beyond it. So we need the control. We need to understand the atmosphere and onboard anomalies and the system to calculate its anomalies by itself and solve it on orbit by itself. So those kind of systems are very much needed as we go through. But end of it, we are in a position to say that how much human intervention is possible on orbit. So that part is also one of the major questions right now. As the constellations grow, as the number of satellites grow, how much human intervention is actually possible by the ground operator? So this kind of scenario is very overwhelming to understand and operate in itself. So this kind of scenarios I keep working on and make sure that we add autonomous behavior in our orbits as much as possible to reduce the difficulties of the operations management and planning and many different aspects of it as we advance through this new space era. So definitely we have LEO, low Earth orbits being essential for us, for our operation, climate change observations, and many different explorations. So even astronomy is coming into picture with low Earth orbits as much as possible. We have ISS on the low Earth orbit and a lot of different small satellites being operated in low Earth orbits. So it becomes very essential to understand what is the scope and dimension of putting these constellations in huge numbers, or optimally designing the orbits and putting the right number of satellites into the orbits. So this all plays a very prominent role, and everybody is trying to put their technological edge into it. A lot of applications from our side are also being planned for life supporting life on Earth, helping a lot of different applications to reduce the infrastructural loss on various platforms. And many technological advances can be tested, but how optimal that can be is a question still to be researched. So my topic is also on that, to optimize the overall aspects of the environmental and human related operation with the LEO region of the satellite operation. So just to give you some overview about the debris, definitely when I talk about LEO region, we have a lot of debris which has to be taken into concern. Definitely the space environment is also changing. So these two concerns are putting up a lot of pressure on the LEO side of it, to make sure that we understand the region properly first, the requirements of it, the problems of it as a whole, because the sun's activity is changing every few days. It's not even months anymore. So the sun's activities are changing every 27 days as per the astronomical data coming in, and a lot of things have to be done on this side to make sure that we understand the environment first and then implement our technology as a whole. The reason I'm sharing this slide is just because the FreeFlyer has many different options here, icons or the features where you can actually understand the realistic situations on ground, on the orbit, and analyze it on ground situation, by syncing the ground operation and the on-orbit satellite together in many different ways. So space debris is one part of it, but you can also set a lot of parameters regarding the space environment. Maybe it is atmospheric drag or solar winds or many different activities related to the space environment can be inbuilt in FreeFlyer very easily and be tested. So coming back to the constellations part of it, I keep going through the Starlink, what it taught us in over years, with so many satellites being planned and functioning. Definitely the scale is the one which can be optimized further, and the laser communication is fully under trial as per the reports, but definitely we have to understand that the satellites are also being affected a lot in recent times with geomagnetic storms, and how basically this can be tested and analyzed for the constellations what we are planning. I think the FreeFlyer, the newer version specifically give that edge to that analysis, also to understand the overview of how these factors can be taken into consideration while building and analyzing the satellite or propagation, constellation propagation, or any aspects of the satellite orientation in the LEO orbits. So definitely when we go for deep space dynamics, definitely there are different amount of features, very specific to Moon, Mars, and beyond. But as you dig into more FreeFlyer kind of icons, I would say features, there are too many different things to explore, and I was blown out of my mind how much work the FreeFlyer team has already done into this, and how much to learn and absorb to understand the overall aspects of the deep space dynamics which FreeFlyer has put in. But once said this, what exploring these part of it would mean to us would be very interesting. The logistic part of it and cost is increasing every time with deep space dynamics, but these aspects can also be tested and put in very different manner on the FreeFlyer platforms, FreeFlyer software. So do we have enough resources? Definitely not. We have to test them. And once we understand the environment of what research we want to put in, what parameters we want to include, then definitely FreeFlyer is the stage where we can perform our analysis and put out our results and display what our analysis or our overview of that particular situation is. So this is one of the phenomenal parts which can be checked and experienced in FreeFlyer very easily. Definitely, we want to sustain. We do not want our satellites to fail before the intended mission time. So we have a lot of applications coming in at various orbits, and FreeFlyer is definitely capable to to test most of this orbits and beyond. And applications, when I talk about, it's about not only restricted anymore to the science and exploration. It's lot of environmental monitoring, surveillance. I mean, lot of military and political oriented satellites and navigation. A lot of research and development is also in place. So too many things to absorb, but definitely the scope what FreeFlyer 7.7 and now 7.8 would give is phenomenal in many different ways. So I'm yet to test the 7.8, but as far as I have worked on 7.7, it covers most of these areas very specifically. Talking about ARTEMIS very briefly, I would say we are also part of ARTEMIS in research and motivation part of it. How much we can absorb and analyze these part of things is one of the main motivations I get usually to understand what exactly is going on with ARTEMIS 1 and what features we can actually try to put in the FreeFlyer software and get our analysis done for cislunar or beyond it. So even we talk about Moon to Mars, the trajectory planning, and also the atmospheric propagation in Martian atmosphere is very interesting to be analyzing for that part of the region as well. So part of the ARTEMIS is being a pride. Definitely, we look forward for the further operations. We are also part of the research and development in some way for the payloads part of it. But as the time progresses, I think a lot of interesting facts could come out with ARTEMIS. And thanks to the panelists as well here, because they have shown what cislunar space looks like overall in the coming versions of FreeFlyer or the present ones. It's mind-blowing overall. And talking about the potentials of supporting operations, definitely the parameters and the scope which FreeFlyer offers is next level. I have myself experienced and have tested a lot of different operations for lunar orbits and some portions in Mars. It actually the visualization gets very connectable and relatable in many different manners with Leo, but overall the scope which it offers is beyond any other software globally at this point. So CAPSTONE, definitely it's a very big success for us at this point, for entire humanity or the small satellite community. I would say the FreeFlyer software also, we have been trying to simulate the same for NRHO orbits, but lot is to be done in coming time, and I'm very excited that what next holds for the lunar orbits in coming time. So how we maintain and sustain such unknown orbits like near rectilinear halo orbits. So this is something a very important door opening for the small satellites, which we take pride in to test, analyze, and I think in next few expos I would come up with some more results and analysis what I have done on this side of the research as a whole. So definitely, there is a lot of boom coming up here on this side that constellations have to be built for cislunar space, and definitely many different aspects are relatable and could be achieved in sometimes because of not only because of the political reasons, but also the excitement in the research industry for after the success of Capstone is phenomenal, and people researchers, universities would like to test their technologies as much as possible in this given strategic new space era. Definitely, we have a lot of different applications for Leo. Now it's the list keeps growing every single time. We want to observe a lot of different parameters and given limited scope, but mainly we intend to have better imagery for the region. There are a lot of scopes for the space environment monitoring, space weather. Definitely, communications is one important, most crucial, I would say, operations for Leo right now, and then going to the national level applications, then you have to have the intelligence and reconnaissance applications as much as possible. The reason to show this is because there are no boundaries to this. You can actually go ahead and then explore your own applications using FreeFlyer at various platforms. You can configure and analyze everything with your own set of parameters in your mind for a particular application. So it's very feasible, customizable, and gives you a lot of scope for your research. So deep space as well. When we talk about Leo, we talk about deep space in the similar manner, where communications are very, very important, and we want to demonstrate a lot of different scientific and technological aspects in coming times. So let's talk a little bit about the Asian market, how we take new space era to be. It's growing, it's emerging, and it's being aggressive in some time. And there are challenges, but they are being addressed, and we are moving not in line with the North American pace, but we are catching up, trying to get as much as possible in a very limited time, and the competence what we have globally, setting new norms to it, and clusters are being formed in Asia for small satellite. Um, uh, Both for constellations and in normal satellites, individual satellites as well. But the reason to show this is because this is growing, this is getting better, this is getting enhanced even in Asia. So there's a lot of scope for FreeFlyer users in Asia to use it. And experience the real-time parametric analysis through this Astro Dynamics software. So Korea, where I actually live, South Korea, we do a lot of different activities here on small satellite. It's a very aggressive market. Uh, every day, this is a new challenge and excitement for us after the Nuri launch, the satellite, the launcher, which has been very successful in this year, which opened a lot of doors for Korean market in this peninsula. Um, Not only for the domestic market, but the overall global market is very excited of this success of Nuri rocket. Um, the small satellite market specifically is very aggressive here. It's growing. Clusters are being formed. A lot of different enhanced strategies are being made. And in next few years, definitely this region, specifically the South Korean region, will become very competent globally, as well as it has that potential to show up to the globe about the small satellite leadership in this region specifically. So there are a lot of collaborations happening, developments with meaningful technology. We are bringing in self-developed technologies on floor to test, analyze, and then in next few Nuri launches, we would test many of our technologies from homegrown companies as a whole. So there's a lot going on in this side, and we have worked with FreeFlyer, and FreeFlyer particularly is growing very well in this country, and I take the pride in that I was the starting point when actually FreeFlyer came into this region, and we had this opportunity to work together. So talking about my journey specifically a little bit, I started with 7.5, went through 7.6 and 7.7, and now waiting for the 7.8 to be tested on my computers. But the growth I have seen, the reason I wanted to show this slide particularly is that the FreeFlyer team keeps the track of the changes and the experiences the users have. It's a very user-centric software, comes up with a lot of different operations, support most importantly, and then gives that ground to explain the problems what users go through. So every time when you see a new version, it's an extract of the user experience as a whole. So that is what my experience also has been through all these versions, and I cannot wait to have the 7.8 version coming up, and then I test my solutions into it. So this has been a phenomenal run since 4 or 5 years for me, and then expect in coming time this would be going at a different level altogether. Important features, definitely, as I work for Constellations now, you can script whatever. It's very customizable. Script whatever you want, and then keep testing your aspects of your ideas in different way, and keep analyzing it in a very simple and precise manner, because the icons which FreeFlyer provides in as a whole, it gives a different touch and edge with other softwares as a whole, and the environment is quite dynamic in as a whole, and as the versions come up, more and more options are added, so that it has no match as a whole. So I usually keep up with my fundamentals as much as possible. So by reading the books, I make sure that I have my grounds on astrodynamics as much as possible. So you can actually anytime go through the help section and keep reading the aspects of learning different parameters, features on FreeFlyer as much as possible, and keep up the fundamentals as much as possible, which I'm doing myself as well. So concluding remarks, just a huge thanks to the FreeFlyer team from this association since a very long time. FreeFlyer holds a very important position in this new space era, and the demand and supply of this era has to be balanced, and FreeFlyer stages itself in a very different and very unique level at this point. So maximizing potentials to attend both the LEO and deep space, which is our quest from our side also to put in efforts on LEO and deep space as much as possible. We have common working goals, which is exceptional in many ways, and then going towards the progressive research and development part of it. So these are some of the references I usually go through, and I wanted to discuss a little more, but due to the time constraint, I would leave it here and open the floor for the questions, if any. Thank you so much.